So for this demo, I'll be using a Raspberry Pi, the Raspberry Pi camera, and the Raspberry Pi SenseHat. I'll be setting up multiple local resources to use my camera within my Lambda functions. To use my camera, I'll connect to /dev/vcsm and /dev/vchiq. And to use the SenseHat, I'll connect to /dev/fb1. As you can see, I'm only using the Pi SenseHat for its LEDs. Of course, I'll be using AWS Greengrass machine learning inference to detect objects in my images. For this, I'll be using a SqueezeNet model. SqueezeNet is a lower footprint model requiring less parameters whilst maintaining a high enough accuracy. It's a great model for low power devices like the Raspberry Pi, and since my Raspberry Pi doesn't have a GPU, it's a great fit. So let's switch to my AWS Management Console for AWS Greengrass. This is the AWS Greengrass console. From here, you'll start defining your new Greengrass cores, groups, and devices. I've already created a group for this demo, so let's go have a look. As you can see, I already have multiple Greengrass groups for projects I've been working on. The Greengrass group defines a Greengrass configuration. In a way, it packages all the IoT resources that are part of a Greengrass deployment. Let's have a look at my Innovate 2018 group. The management console for my group shows the following. First, I can see all the deployments I made to this Greengrass group. As you can see, I've been quite busy deploying numerous times, effectively trying to get my model and demo to work. Each deployment is a package that will contain my Lambda functions, my machine learning models, and all configurations intrinsic to the Greengrass group. I can see the subscriptions, cores, devices, Lambda function, and resources specific to this group. For this presentation, let's have a look at the basics for now. Let's have a look at my Greengrass cores for this group. In a group, you'll define the first device, the Greengrass core. In my group, I only have one core. If we look at its details, you can see it actually is an IoT device or thing. It will have its own AWS IoT X509 certificate. The Greengrass core has its own shadow, and you can interact with it the same way you would as a normal AWS IoT thing. The connectivity information provides details on how a device locally within a group could reach the Greengrass core on the local network. Coming back to my group, you can also define within your group any other potential IoT devices that you want to connect to the Greengrass core. In my demo, I don't have any other devices. I'll only be leveraging the Greengrass core device. Before having a look at the Lambda configuration, let's have a look at the resources that I've configured for this group. This page will list all of the configured local resources for my Greengrass group. For this demo, I've set up multiple resources, 3 device resources and 1 model resource. The 3 device resources refer to the 3 different peripherals or hardware devices on my Raspberry Pi. If, say, I wanted to use a GPU, this is where I would declare its configuration and source. For the demo, I'll be using the SenseHat device, which is located on /dev/fb1, and the camera, which is located on /dev/vchiq and /dev/vcsm. For the video interface and video share memory respectively. Basically, these are the Linux device files I will need to read and write to in order to interact with my hardware peripherals. Let's have a look at my model resource. Here, I've defined a machine learning resource. You can select to bring your own pre-trained model by storing it in an S3 bucket, or you can provide a training job source using Amazon SageMaker. If I select the training job source, we can select the training job from my SageMaker jobs. For the purpose of this demo, I'm using my pre-trained model and I'm loading it from S3 bucket. Then I need to select a local directory on my device where the model resource files will be extracted to. Note that these will be tied to the context of the Lambda function using that resource. And this is a great segue to having a look at my Lambda functions. You can see here I have two Lambda functions. They serve two very different purposes. Note that these Lambda functions are actually stored and managed from a versioning and aliasing perspective in the AWS Lambda Management Console. These are the same Lambda functions you are accustomed to writing and managing. The only difference is where they will actually be running and how. My first function, the Greengrass Object Classification 4 function, is the Lambda function that will be doing the inference on my images by using my SqueezeNet pre-trained model. You can configure your Lambda functions to run indefinitely or triggered on demand. This function runs indefinitely. We will be analyzing the video stream one image every 30 seconds. So we'll let it run all the time. No need to trigger it on demand. If we look at the resources this Lambda function is using, you can see I've associated 3 of the resources we declared in the previous step. I need my Lambda function to access the 2 video camera device resources and the SqueezeNet model resource. With these 3 resources, my Lambda function can easily start capturing images from the video feed and send them to the model for image recognition. Now, my second Lambda function is the very simple Lambda function that will act on the recognized information from the first Lambda function. This function does not run indefinitely and is triggered on demand. I want this function to parse the inferred results and trigger the LEDs on my Raspberry Pi SenseHat. As you'd expect, for this demo, I'll connect this Lambda function to my SenseHat device resource. If my model detects a coffee mug, then I want my LEDs to turn blue. If not, they should stay red like they are now. It's a simple demo to showcase how you can act on your data at the edge on inferred data. No need for internet access. You can act in real time. All the sensing, inferring, and acting on the data is happening locally on my Raspberry Pi. Last bit we need to look at is connecting everything together. We need to define our subscriptions. This tells Greengrass how the data gets connected from one Greengrass resource to the next. I've written my recognition Lambda function, the Greengrass Object Classification 4 function, to publish the results of the inference on the Innovate 2018/Inference MQTT topic. So I've created a subscription that tells my SenseHat Lambda function to subscribe to that topic with my recognition Lambda function as its source. This will allow for the recognition results, the inferred information, to be passed to my LED function. If my model recognizes a coffee mug, go blue. Okay, so once all of this is properly configured, I can simply deploy onto my device. For the interest of time, I've pre-deployed this configuration. So let's have a look at the incoming data. Since I'm running inference at the edge, I'm actually not sending the data back to the cloud. So let's log into my Raspberry Pi to look at what my Lambda function is receiving. As you can see from the feed, my demo sends data every 3 seconds. And the laptop I've placed in front of the scene is being detected, here called the notebook. Small disclaimer here, my model isn't perfect. Depending on the scene in front of the camera, the model is detecting some pretty obscure shapes with pretty low probabilities. The probabilities aren't great for those detections, showcasing I may need to train my model a bit more in order to get better results. This is a great case for leveraging SageMaker to improve my model. For now, this will be enough. All I'm trying to do is detect the presence of a coffee mug. So what happens if I place my coffee mug in the scene? There it is. My LEDs have turned blue, and we can see from the feed that we have detected a coffee mug, this time with a small probability. If I remove the mug, we should turn back to red. Great, it works.